everyone, we are going to learn about the fifth lab experiment, that is, design a 4-bit full adder and subtractor and stimulate the same using basic gates. This is the full adder and subtractor. How to design the 4-bit subtractor circuit? By cascading 4 such full adder blocks, we can easily design the 4-bit adder. So after that, we have also seen the circuit for off subtractor and a full subtractor. So similar to the adder circuit, by cascading n such full subtractor blocks, we can easily design the n-bit subtractors, and here the design of the 4-bit subtractor is shown. So as you can see here, the 4 subtractors are connected in the parallel connection, and the output barrow from the one subtractor is given as an input to the next subtractor. So this is the circuit performs the A minus B, where both A and B are the 4-bit numbers. So let's say two numbers are 1 1 1 0 and 0 1 0 1. So if you perform the subtraction using this 4-bit subtractor, then for this first full subtractor block, this A0 is equal to 0, while this B0 is equal to 1, while the incoming barrow is already equal to 0. So here this 0 minus 1 is equal to 1, and the output barrow will also be equal to 1. So now in the next column, this A1 is equal to 1, while the B1 is equal to 0, and the incoming barrow is equal to 1. So here 1 minus 1 is equal to 1, and this 1 minus 1 is equal to 0. That means the difference is equal to 0, while the barrow is also equal to 0. So now in the next block, both A2 and B2 are 1. That means this 1 minus 1 is equal to 0, and since the incoming barrow is equal to 0, so the 0 minus 0 is equal to 0. That means both difference and the barrow output are 0. So now in the final block, A3 is equal An is equal to 1, while the Bn is equal to 0, and the incoming barrow is equal to 0. That means that output is equal to 1 0 0 1. The output for D0 is 1, D1 is 0, D2 is 0, and Dn is equal to 1. So in this way, by cascading 4 such full subtractor blocks, we can easily design this 4-bit subtractor. As per this design, if you want to do the addition and subtraction of the 4-bit number, then we require two separate circuits. One circuit for the addition and one for subtraction. Then the 4-bit full adder subtractor. A 4-bit adder and subtractor is a digital circuit that performs both addition and subtraction operation on binary number consisting of 4 bits. It combines the functionality of an adder and a subtractor in a single circuit, allowing for efficient arithmetic calculation. How does a 4-bit adder subtractor work? The circuit uses a combination of logic gates and flip-flop to perform addition and subtraction. It takes two 4-bit binary numbers as input, along with a control signal that determines the operation to be performed, may addition or subtraction. The circuit performs the corresponding operation based on the control signal utilizing binary arithmetic principle and carry or borrow mechanisms. Key component of a 4-bit adder and subtractor. A 4-bit adder and subtractor typically consist of 4 full adders which are interconnected to handle the addition or subtraction of individual bits. Additionally, multiplexer or control gates are included to control the flow of data and select the desired operation. Next, 4-bit binary adder subtractor circuit. This is the circuit. This control input is equal to 1. Then the output of the XOR gate is the complement of the number B, and whenever this control input is equal to 0, then the output will be same as the input, and here the control input is also given as the input to this CO. That means whenever we want to perform the addition, then this CO is equal to 0 and all the XOR gate will pass B input as it is. If the control line is 1, the operation would be this. It is being performed on 4-bit number is subtraction. Similarly, the control is 0. The operation is A plus B, which is simply binary addition. Thus, the control line acts as switch for adder and subtractor circuit. Let's consider two binary numbers A and B as input to the digital circuit for the operation with digits. The circuit consists of 4 full adders. Since we are performing operation on 4-bit numbers, there is a control line K that holds a binary value of either 0 or 1, which determines that operation is carried out is addition or subtraction. As shown in the figure, the first full adder has a control line directly as its input. The input A0 is directly input in the full adder. The third input is the XOR of B0 and K. The two output produced are sum or difference and carry. If the value of K is 1, the output of B0 K is equal to B0 bar. Thus, the operation would be this. Now, to complement subtraction for two numbers A and B is given by A plus B dash plus C in. This suggests that when K is equal to 1, the operation being performed on the 4-bit number is subtraction. Similarly, if the value of K is equal to 0, the B0 K is equal to B0, the operation is A plus B, which is simple binary addition. This suggests that when K is equal to 0, the operation is performed on the 4-bit number in addition. Then C0 is serially passed to the second full adder as one of its output. The sum or difference S0 is recorded as the least significant bit of the sum or difference. A1, A2, A3 are the directed input to the second, third and fourth full adders. Then the third input is B1, B2, B3 XOR with K to the second, third and fourth full adders respectively. This carry C1, C2 are serially passed to the successive full adder as one of the inputs. C3 become the total carry to the sum difference. S1, S2, S3 are the recorded to form the result with S0. For an n-bit binary adder subtractor, we use n number of full adders. Then this is the Verilog program for full adder and subtractor. In this program, module is a keyword and this is the module name, and these are the input and output variables. The input variable is A and B, then the output variable is sum, difference, and in this case the wire C1, C2, C3, C4 as well as B1, B2, B3, B4. Wire is nothing but a piece of wire. to connect two modules or to connect two blocks are designed. And finally end with the end module. And this is the output for this Verilog code. The input name A and B, then the value for A is 0 1 1 1 and B is 1 0 1 0. Then the output difference is 1 1 0 1. This is the output for this Verilog program. Finally, instead of designing two separate circuits for addition and subtraction, we can perform the two separate operations using a single 4-bit adder subtractor circuit. It reduces the usage of more number of logic gates and reduces the cost and complexity of the design. The application of a 4-bit adder and subtractor. The 4-bit adder and subtractor find application in various digital systems such as arithmetic calculators, microprocessors, digital signal processor, and control units. They are essential for performing arithmetic calculation in this system accurately and efficiently. Thank you.